shock waves.
But it's squid ones now. Squid is pretty. How slow it's I don't. Yeah. No. Yeah, I think that is so
All right, we need our notebooks out. We're going to pick up where we left off yesterday with the chain rule. Remember the quiz on Monday on the trig derivatives, no partial credit. Okay, we're talking about how we could differentiate functions of this form. Now, we started by talking about 3x plus 5 quantity squared, and we said we could expand that, we could write it as a product and use a product rule. And then once we moved to the third power, we said we still had those options. But if we start increasing the exponent to the 20th power, then the 200th and the 2000th, those approaches really aren't really, I guess, easily executed, we'll say. So we need a better way. All right, so when dealing with composite functions, we want to be able to deal with them in their given form. So we have to first start by figuring out what the inner function of the composition is. And what is that in this case? Inner function of the composition. 3x plus 5. So we're going to let u equal 3x plus 5. And then we're going to rewrite y as a function of u. So what's y as a function of u? Y equals u to the 2000. All right, so now we have two simpler functions, neither of which is the composite function. And we can differentiate each one using simpler means. All right, so we're going to find du dx. If u is equal to 3x plus 5, du dx is 3. All right, and that's on a very simple level compared to what we're doing now. All right, much simpler rules. And then we're going to find dy du. That's 2,000 to the 1999. So just one application of the power rule there. Also, much simpler problem. All right, now we have du dx and dy du. But we don't want either one as an end result. We want dy dx. So some impulse control. We got a little bit farther in period 1-2 yesterday, but I had people blurting stuff out without thinking about it, and they were saying some nonsensical things here. If we have du dx and dy du, what can we do to find dy dx? Aaron?
Can you just plug 3 in for you? Oh, not plug in.
God, no. No!
The door is right there.
It's on film. It's on film. You gotta pay Elisa to edit that one out. You set a price later. All right, let's have something more sensible. Alright, no, we gotta think, we don't wanna have these delays like we did yesterday and keep falling more and more behind. Yeah,
Substitute 3 in for you.
but 3's not equal to you.
Uh,
3's du dx.
interesting.
Let's do 3x plus 5 for you.
These are guesses and they're not, 'cause that doesn't give us dy dx, that gives us dy du as a function of x. We want dy dx. Steph,
Can you multiply them?
what do you mean by that?
Du over dx times dy over dx?
Yes. Right. dy du times du dx. Let's look at the algebra behind this. What's du divided by du? 1. So we're left with dy divided by dx, which is what we want. Okay. So that's not a guesswork thing. That's valid algebra. Okay. So dy du is 2,000 times u to the 1999th power, and then times du dx, which is 3. So we get 6,000 times u to the 1999th. We're not done yet. There's one more thing we need to do. What is it?
Substitute 3x plus 5 in for you.
Good job. Proper use of target language.
Way to redeem yourself.
All right. There's no u in the given problem. What we're doing here is called a back substitution. All right, we substituted 3x plus 5 out of the expression. Now we're going to substitute it back in. We never took the expression out of its factored form, so our derivative ended up in a factored form. Okay? What we just used is called the chain rule. Purpose of the chain rule is that it is used to differentiate composite functions. All right, it's a heavily tested topic on the AP exam, so don't be surprised there's 4 or 5 multiple choice questions out of the 45 that hit this topic. All right, disproportionately high amount of testing. Okay, let's say we want to find dy dx if y equals the square root of 4x squared minus 1. What you have to understand is that the questions will never say use the blank rule, use the quotient rule, use the product rule. That's something that you need to identify. Now, first thing, this is not equal to the square root of 4x squared minus the square root of 1. There is no property of exponents for that. That's an illegal algebra step. That kind of work gets you a big red X and awards you no points because you didn't do anything that was correct. Okay, in a problem like this, we had a workaround. We could expand it if we want. We could use a product rule. This we have no workaround. We can't expand it because it's really this. All right? Can't do binomial expansion with exponents like that. I hope that you never made a Pascal's triangle with an n equals 1/2 row. But if you did, I'd love to take a look at it. Okay? I don't know how that would happen. But this is a problem where there is no workaround. You have to use the chain rule, okay? It's like there's certain problems you can work around the product rule. Like on the quiz, I gave you a problem that you could have expanded and gone turn by turn. Or you could have used the product rule. Here, you have to use a chain rule. There is no alternative strategy. Okay, so what is the inner function of the composition?
Squared minus 1.
4x squared minus 1. So that's u. And then what's y as a function of u?
Y equals u to the 1/2.
U to the 1/2. Okay, and we wind up with two functions, neither of which is a composite function, that we can differentiate using simpler means that we previously learned and mastered. So du dx is 8x, and dy du is 1/2 u to the negative 1/2 is 1 divided by 2 squared of u. All right, now that strategy that Steph gave us, the multiplying du dx times dy du, that was not specific to that problem. That is a generalized strategy. All right, so we could say again, dy du times du dx is 1 divided by 2 squared of u times 8x. We're going to simplify as much as we can in this form, and then when we're tapped out there, then we back substitute and we see if there's any subsequent simplification. All right, so we have 4x divided by the square root of u, all right, the 8 divided by 2. And then we do our back substitution. We get 4x divided by the square root of 4x squared minus 1. Okay, so you could see a problem like this on the AP exam right here. It would be non-calculator multiple choice. Something like this. You could work around the chain rule here. You could say it's cosine of x times cosine of x times cosine of x times cosine of x times cosine of x, and extend the product rule to the product of 5 factors. That is extremely inefficient. All right, so instead what we want to do, and I strongly advise you to do this because you have about 15 minutes of experience with the chain rule. Okay, not even. Write it like this, and you can more clearly see the composition. When you have those grouping symbols, you can see the inner function, the outer function. What is the inner function of the composition here? U equals cosine of x. All right, never under any circumstances should you be writing u equals x. If you write u equals x, that means either you didn't have to use a chain rule or you're not selecting your u properly. All right, and then y equals u to the 5th. Okay, two simpler functions that we could differentiate with prior knowledge. Okay, what is du dx equal to? The opposite of the sine of x. Remember, if a trig function starts with co, its differentiation rule, its derivative starts with a negative sign. All right, and then dy du,
5u to the 4th.
5u to the 4th. All right, simple application of the power rule, which we should have mastered. If you haven't mastered the power rule by now, you're way far behind where you need to be. All right, so dy du times du dx is 5u to the 4th times the opposite of the sine of x All right, then we need to do our back substitution.